Welcome to Guide Guru. We hope this video helps.
Convolutional neural networks process images using local receptive fields and shared weights. A convolution applies a 3x3 kernel across the image with stride 1. Each convolution uses 32 filters to learn different local features per layer. After convolution, we apply a re-LU activation to add nonlinearity and speed training. Batch normalization stabilizes learning and helps use higher learning rates. Pooling reduces spatial size with a 2x2 max pool and lowers computations. Finally, deeper layers combine features into classifiers for final predictions. A typical CNN alternates convolution, activation, and pooling in sequence. Stride 1 convolutions preserve spatial resolution before any pooling operation. Pooling typically uses a 2x2 max pool to reduce spatial dimensions by half. Dropout can be applied to prevent overfitting during training with a 0.5 dropout rate. Fully connected layers then map extracted features to output classes for classification tasks. Softmax converts final outputs to probability distributions over labels. Training uses cross-entropy loss and stochastic gradient descent. Train a CNN end-to-end with labeled image batches and forward/backward passes. Use cross-entropy loss and SGD with momentum for stable training updates. Start with a learning rate like 0.001 and reduce it with schedulers as needed. Augment images using random flips, crops, and color jitter to increase dataset size and improve generalization. Monitor validation accuracy and stop when improvements plateau to avoid overfitting. Save model checkpoints and resume training if interrupted or to experiment with settings.
Thanks for watching. Consider subscribing if we helped you today.